Hello guys, can you all see me? Of course yes, but how? The reason lies behind is chemistry. Our vision has a protein called as rhodopsin which has a helper molecule called as cis-11 retinal. An important phenomena occurs on cis-11 retinal which helps us to see. But what this phenomena is? Don't worry, we are going to talk about this later in the video. But for now, my name is Nidhi Tater and today we are going to talk about isomerism. Also, we are going to study the different types of isomerism. The word isomerism is derived from two Greek words. Isos means parts and meris means equal. So basically it refers to the bilateral similarity and if not, the equivalence of structures. So the phenomena of occurrence of two or more compounds having the similar molecular formula but different property is known as isomerism. And these compounds are called as isomers. Isomerism is broadly divided into two types.
The first one is structural and second stereo. Let's talk about structural isomerism first. Structural isomers are compounds having same molecular formula but different structures. And this phenomena is referred to as structural isomerism. Basically, they have different carbon structures. Structural isomerism is further divided into four types. First, chain isomerism. Second, position isomerism. Third, functional group isomerism. And fourth, metamerism. Let's talk about chain isomerism. When two or more compounds have similar molecular formula but different carbon skeletons, they are referred to as chain isomers.
So let's take an example of butane which has 4 carbon atoms and 10 hydrogen atoms. If I basically try to draw the structures of butane, we can have two structures basically. The first one is N-butane, which is a straight chain structures in which all the carbons are arranged in a straight chain. And the second structure that I have is isobutane. See, in this, 1, 2 and 3. 3 carbons are arranged in a straight chain while this carbon is branched on the second carbon. So we have the same molecular formula, that is C4H10, but different structures. That is, butane is called as chain isomer. Oh yeah, we have here H also. I just forgot to mention, yeah.
Now let's talk about the position isomerism. When two or more compounds differ in the position of the substituent atom or functional group on the carbon skeleton, they are referred to as position isomers, and this phenomena is termed as position isomerism.
So let's take an example of bromopropane. As we have this, so it is named as 2-bromopropane. Now, and second again we have 3 carbons. Now if we attach the bromo group to the first carbon atom like this, let me number it. First carbon atom, then it will become 1 bromopropane. As we see that the molecular formula is same, C3H7Br for both the isomers, but since the position of the functional group, that is Br, is different, that is why these both are position isomers.
Let's see the third type of structural isomerism, that is functional group isomerism. When two or more compounds having the same molecular formula but different functional groups are called as functional isomers, and this phenomena is termed as functional group isomerism. Let's take the example of C3H6O2, which has two functional group isomers, the first being the propanoic acid. Propanoic acid has a functional group carboxylic acid group. The second isomer is methyl ethanoate. Which has the functional group ester. Thus, C3H6O2 has two functional group isomers. Let's look at the last type of structural isomers, that is metamerism. Metamerism arises due to different alkyl chains on the either side of functional group in the molecule. Metamerism can also arise due to the ring structure, which is greatly restricted. Look at the example of metamerism. We have a molecule C4H11N in which in NH, in the first molecule there are two ethyl groups on the either side of NH, and in the second isomer we have one methyl group on the one side of NH and the propyl group. So thus we have different alkyl chains on the either side of functional group, which shows metamerism. Now let's talk about the second type of isomerism, that is stereoisomers. The compound that have the same constitution and the sequence of covalent bonds but differ in the relative positions of their atoms or groups in space are called stereoisomers. Stereoisomers are further divided into two types. First, geometrical, and second is optical. Okay, let us take an example of butene, in which there is a double bond between the second and the third carbon atom, due to which there is a restricted rotation around the double bond like this. Thus, we obtain two different types of spatial arrangements. When the identical group are present on the same side of the double bond, it is known as cis isomer. And if the identical groups are present on the opposite side of the double bond, it is referred to as trans isomer. So thus the name of this molecule is cis but 2-ene, and the name of this is trans but 2-ene.
remember that we talked about cis-11 retinal in the beginning of the video? Yes. In the exposure of light, cis is converted to trans, and during the conversion of the isomers of retinal, the light energy is absorbed, which is then given off to the proteins, which transports through the visual system, thus enabling us to see the whole beautiful world. Now we're talking about the second type of stereoisomer, that is the optical isomerism. Before talking about optical isomerism, I would like to introduce that optical active compounds are those compounds that rotate the plane polarized light. And if the plane polarized light is rotated in the clockwise direction, it is called as dextrorotatory compound or the plus pole. And if it is rotated in the anti-clockwise direction, it is known as levorotatory or the negative pole. You can remember like D comes after C, so it's clockwise for dextro. So this was all for today. Thank you for being with us. Keep learning, keep smiling.